right, you did the math correctly. They will meet in 3 hours at mile 22. Oh, be sure to take them plenty of water because they'll be thirsty. And don't forget to give them the cookies I baked. Well, I'm about to go for a run myself, so I'll talk to you later. Bye. Hi, it's Mia, and I just got finished talking to my friend Justin, who is getting ready to take supplies out to 2 guys in his unit who are doing a training run this weekend. Justin needed to determine where and when to meet up. He had done his calculations, but he called me just to double check. It's a good example of writing algebraic expressions and equations. Why don't we review our work so you can see how we got another problem solved? Justin told me that Scott and Sean each set up camp last night in 2 different places along the trail. Scott at checkpoint A and Sean 1 mile down the trail at checkpoint B. By drawing a line to represent the trail, we can see where each runner is at on the trail when Sean starts out. This morning, Scott broke camp early and started before Sean. In fact, Scott had run 10 miles before Sean left checkpoint B. Justin told me that Scott has a heavy pack and is running at an average of 4 miles per hour. Sean is a fast runner and isn't carrying a pack. He will be running at an average of 7 miles per hour. What Justin needed to determine was how long it will take Sean to catch up with Scott and where they will meet so he can deliver supplies. Since we know Scott has already run 10 miles, we put a mark here. We also make a mark at checkpoint B to represent where Sean is starting. Let's see where they will be after 1 hour of running. Scott will run another 4 miles, putting him at mile marker 14. Since Sean started at mile marker 1, he will be at mile marker 8 in 1 hour. After 2 hours of running, Scott will be at mile marker 18, or 14 miles plus 4 miles. Sean is really starting to close the gap. He was at mile marker 8 and ran 7 miles in the last hour, getting him to the 15-mile marker. When Scott runs a 3rd hour at 4 miles per hour, we will arrive at mile marker 22. 22 miles, that's quite a run. Look what happens. If Sean continues his 7-mile-per-hour pace, in hour number 3, he will travel from mile marker 15 to mile marker 22 and arrive at the same time as Scott. Therefore, Justin needs to link up with the guys in 3 hours at mile marker 22. Justin thought he figured it correctly using a number line model, but asked me to build algebraic expressions to check his work. I will show you what I came up with. Scott travels 4 miles every hour. In 1 hour, he travels 4 miles per hour times 1 hour. For 2 hours, 4 miles per hour times 2 hours. So for an unknown number of hours, we use the expression 4 times h, where h equals the number of hours. We also know that he was 10 miles from checkpoint A down the trail when Sean started out. So the distance, d, equals 4h plus 10, where d is the distance Scott has run from checkpoint A. Sean travels 7 miles every hour. In 1 hour, he travels 7 miles per hour times 1 hour. For 2 hours, 7 miles per hour times 2 hours. And for an unknown number of hours, we use the expression 7 times h, where h equals the number of hours. Finally, we know that Sean's starting spot was 1 mile down the trail, so the total distance he will travel from checkpoint A is d equals 7h plus 1. Since we want to know when the two will meet, we set the expressions for the distance each is from checkpoint A equal to each other. 7h plus 1 equals 4h plus 10. We can check our answer by substituting 3 hours for h. 7 times 3 plus 1 is 22, and 4 times 3 plus 10 is 22. since it checks, 3 hours is correct. So if Justin arrives at mile marker 22 in 3 hours, he will be able to give the guys the supplies for the next leg of their journey. See? Creating algebraic expressions and equations for problems can be a useful strategy to quickly solve or check a problem solution. You can use algebra to solve lots of problems. Well, it's time for me to go on my run. I don't think I'll be running 22 miles, but I'm working my way up to that. That's another problem solved.